Hi, I'm Andy Welton, and I'm a Purdue University professor that is going to moderate tonight's webinar. Tonight's webinar is about the LA pool study and really understanding what was in the water after the wildfires and what to do about it. Before beginning, I'd like to say several special thanks to individuals and organizations. First and foremost, the households and businesses that participated in the pool study, provided us pool water, let us access their properties, are greatly appreciated. Without them, this would just not have been possible. Faculty, staff, students, and others at participating institutions also volunteer their time. And community groups such as Pally Strong and Eaton Fire Residents United also encouraged community members to participate. So thank you. This work was funded by the R&S Kane Foundation, as well as participating universities. This effort was part of the Community Action Project Los Angeles, or CAP-LA effort. LMU also shared some of our study information with households and connected us with CAP-LA. So tonight, I'm going to share a brief overview of what we're going to do, and then I'm going to hand it off to the study leader. Tonight, we'll talk a little bit about introductions. We'll then move to an incident overview, a question and answer period with a panel of experts. Finally, we'll wrap up and end. A recording of this event will be posted at plumbingsafety.org. And if you want to right now, you can go to that website and click on the presentation PDF file so you can see what we're looking at right now. This pool study was initiated in response to the January 7th LA wildfires, specifically the Eaton Fire and the Palisades Fire. Shortly after that, households reached out to us about whether or not they had proper testing procedures or actions needed to determine if their properties were safe to come back to and what they should do about it when they found contamination. To help households expedite their recovery, a team from Purdue University visited the area February 7th to the 12th. That travel was supported by the R&S Kane Foundation. During that time, we met with households and visited their properties, talked with government officials in both fire impact areas. Pools were a frequent topic, and households basically were told a number of things and sometimes conflicting information. One, they were told not to discharge pool water into the storm sewer. Others were told the water is toxic, it needs to be replaced. And others were told simply, don't drain your pool water. So many people were asking us, what do I do with my pool? Next, what we saw was a team came together with all different expertise to kind of help people understand what was going on with their pools and what to do about it. You're going to hear a little bit about that tonight. I'm going to introduce to you Dr. Caitlin Proctor. She is the study leader and assistant professor of environmental engineering at Purdue University. She has over 15 years experience in water quality, monitoring, testing, building systems, as well as private properties. You're going to hear from some of the other study leaders later on in the session here, but at the present time, I'd like to kick it to Dr. Proctor.
Thank you for that introduction. I am so excited to share with you all what we learned from the LA pool study. So I became involved in this in late February or March 2025 after Dr. Welton was receiving some of those calls, and we were very interested in what was going on. So before I get too far into the details, I do just want to repeat a thank you to all of the people involved, especially the students. Students were critical to the success of this project. They helped create a sense of community around our sampling collection and were very critical. We also had some students at Purdue providing extra logistical support and just brought together a really amazing team. The motivation for this study, as Dr. Walton mentioned, was that we did see contamination from these pools, and there was a lot of conflicting advice. The advice that was available online was not necessarily evidence supported. We couldn't find any studies that have documented what happened after pools were contaminated by wildfires and what that contamination was. So there were some government documents, but there wasn't data to support that. And there are a lot of pools in these areas, and the advice was all over the place. Sometimes it was don't discharge this water to the municipal sewer. Sometimes it was don't discharge it to the storm sewer. Sometimes it was do use it to suppress dust, so that would eventually discharge to a storm sewer. There was also a lot of advice surrounding mosquitoes because, of course, as these pools were not maintained over time, this would allow a different hazard to appear. And we received a lot of questions from pool owners. And there's a lot of things that could be in the water. So, organisms, of course, we saw algae growing after a certain amount of time, and debris. So, whether this is ash, fire suppressants, or other things that got into the water, it wasn't clear whether these were hazardous or non hazardous materials, what inorganic chemicals like heavy metals might be involved, and what organic chemicals like SVOCs might be involved. And I will explain a little bit later what those SVOCs are and what that acronym means. So our goal with this study was to better understand the fire's impact on pool water quality and the potential impacts that remediation and cleaning actions might have on that water. To do that, our overarching goal was to sample 100 pools, and we were able to sample around 50 from the Eaton area and 50 from the Palisades area. To break that down into a little bit more of a timeline, in early March, we were able to do an online survey to identify pool owners who might like to participate. We then had a field team investigation where we were able to sample some initial pools with community members. They met us at these pools so that we could take these samples. And then we had continued participant sampling in March and April, where our team was able to give these bottles to our participants. They went out and collected their water, and then there were some initial analyses done. All of our samples were paired with surveys that asked a lot of questions about the characteristics of the pool and the type of remediation and cleaning that was done. We then analyzed all of our water samples for heavy metals and SVOCs, and we really prioritized sharing these results with the pool owners, which we were able to do already. From our initial field observations, we saw a lot of different types of pools and a lot of different water qualities within these pools. So as you can see from these initial pictures, all sorts of different water colors, different pool sizes. Covers were on some of these pools, covers were off on others. Some pool owners were able to treat the pool quite extensively before we got there, and the proximity to burned structures and other burned items really varied. We did see growth, so we saw maybe algae growing or other organisms growing on top of the water, and a variation in colors, and of course, a variation in the proximity to debris from the wildfire. We were able to sample 100 pools. This was from 263 people who were interested with that initial survey. Of those 263, 224 were eligible, and a majority of those pools did not have any maintenance before, after the fire and before we were able to sample. The 100 pools that we were able to sample, most were non-operational. So this we defined as the filter wasn't working yet, and there wasn't any pool testing or balancing done yet. And a lot of them were dirty as opposed to remediated, so there was still debris present, and no chemicals were used. A lot of our pools could be defined as what we called medium, which was 5.5 to 10 feet deep and 336 to 612 feet squared in surface area. Our water samples were taken from the tops of these pools. We then measured that water for heavy metals and SVOCs, or semi-volatile organic compounds. We'll talk about SVOCs a little bit later. Let's focus on heavy metals to start. For heavy metals, we tested 22 of these, and some of these words you might be familiar with, like lead or iron. And for a lot of these metals, there were not recreational standards. So this meant that there wasn't a standard to say this amount of barium is safe to swim in. When there are recreational standards available, these tend to be high because exposure to metals through your skin is not as toxic as exposure to drinking those metals. So none of our recreational standards, when available, were exceeded. But we did want to look a little bit more stringently, so we looked at drinking water standards. Drinking water thresholds are established based on levels that are harmful to health when drinking liters per day for an entire lifetime, so 70 years. And there's a few different kinds. Maximum contaminant levels are enforced by the EPA. Health advisories and suggested limits are not enforced in the same way. These drinking water thresholds were rarely exceeded, but I do just want to emphasize that you shouldn't be drinking your pool water anyways, for reasons like the metals that we're about to discuss, but also for other reasons we should not be drinking that water. When we look at the 22 metals, only 4 exceeded a drinking water standard. So we're going to take a little bit closer of a look at what was going on with those 4. Many of these could also be linked to data from the utility, and we'll explain a little bit more what that means. So, looking at arsenic first. This is a heavy metal that's found in minerals. It can be naturally leaching from geology, but it could also be present in some man-made products like treated wood. There is a maximum contaminant level of 0.01 milligrams per liter or 10 parts per billion. And this maximum contaminant level was exceeded in about 10% of the samples that we took of pools. What we found when we dug deeper into what this data was is that arsenic was significantly higher in the Palisades area, which is utility A on this slide. So pools with utility A tended to be higher than many of our other utilities. This meant to us that it was likely linked to the incoming water from the utility, but it could also be related to the area because arsenic is naturally present in some geology. It could be coming from runoff or wind blown from the area. The next metal that I'm going to look at is lithium. So this, like arsenic, is naturally occurring in some rocks and some groundwater. But of course, we all know lithium from lithium-ion batteries that are present in electrical vehicles. So we were maybe concerned that presence of lithium could be related to EVs. There's a non-enforceable limit, so this is just a suggested limit for lithium of 60 parts per billion. And we found that this limit was exceeded in about 40% of our pools. Now, what we found when we looked a little closer was that, again, lithium varied by water provider. So utility A tended to be higher than all of our other utilities, and there were some differences within other utilities as well. But this concentration was also reflected in the utilities values. So a lot of the values we saw, even though they were higher in utility A, were in line of what we saw in consumer confidence reports. We asked the question, did remediation help? And we did not find any evidence that remediation was really removing lithium, nor did we find evidence that EVs burning nearby contributed to lithium concentrations. So our takeaway from lithium is that this is likely a naturally occurring metal, and it could be unrelated to the fires. We don't have data from before the fires with these same pools, but I do suspect that we would find similar results. Antimony is another metalloid, and this is often used in things like flame retardants, batteries, brakes, things that might have burned in the fire as well. There is an EPA MCL for this, again, a drinking water standard of 6 parts per billion, 0.006 milligrams per liter. And this was exceeded in about 10% of our pools. What we found when we looked at antimony was a little bit different than the other two that we've already discussed. First, it was significantly higher if burned structures were closer. So looking at this graph, 0 to 10 feet, so if a burned structure was less than 10 feet away, the concentrations tend to be higher than if those burned structures were further away. We also found that antimony was significantly higher in pools that were non-operational, so their filters weren't working yet, or pools that had not been remediated, so debris was still present. There was some underlying variability by water provider, but a takeaway from this is that some metals, like antimony, may have been related to burning structures and remediation efforts. But again, concentrations did not exceed these drinking water standards widely. And again, drinking water standards are much lower, much more stringent than what we might want to think about for recreational water. Selenium was a last metal that we found to exceed drinking water standards, and this exceeded in about 4% of the pools. This might have been present, for example, from agricultural runoff or burning of electronics. When we saw these exceedances, they were often in dirty and non-operational pools that were close to a burned property. So our takeaways from metals. Many heavy metals were in fact present in the drinking water provided by the utility. So they were there before the wildfire. And they could also be potentially related to naturally occurring runoff from the geology of the area. Some metals could be linked to remediation and operation factors or other factors like proximity to burned structures, but none were concerning levels for recreational water. So a takeaway from metals is that metals are driven by the water going in more than wildfires, and don't drink the water. Moving on to SVOCs, or semi-volatile organic compounds. These are organic compounds, so related to these carbon structures you see on the left, and they have a moderate vapor pressure, meaning that they tend to stay in the water a little bit, but they might also volatilize, go into the air. These could be present from burning synthetic materials, ash and soot, paints, sealants, all sorts of things can release SVOCs, and they can, of course, be harmful to health. We tested for 73 different SVOCs, and like metals, standards were often unavailable, especially for considering recreational water. So we made comparisons to drinking water standards, so maximum contaminant levels or these drinking water equivalent levels, but we also made comparisons to these ambient water quality standards. And these standards basically answer the question, can I eat a fish from this area? So if a certain SVOC is present in this river, is it safe to eat fish from this river? And what we found, of those 73 SVOCs, only 7 SVOCs were detected in 10 or more pools. None of these exceeded a drinking water limit, but we did have this first SVOC BBP exceeding this ambient water quality limit, meaning don't eat the fish. Looking a little bit closer at this BBP, we didn't see that dirty or non-operational pools had higher BBP concentration than ones that were remediated or operational already. So it wasn't necessarily due to cleaning that this BBP was present. Additionally, unlike metals, we didn't find significant differences by the utility. So really, we weren't sure exactly why this BBP was showing up. But our overall conclusions from SVOC data is that SVOCs did not vary by utility like metals. Most SVCs were not detected in most pools, so we just tested for 73. We only found 7 in 10 or more pools. Only one limit was exceeded, and this limit simply meant don't eat the fish from this pool. It is difficult to draw conclusions with our limited number of detects, and we're still looking at some patterns of co-occurrence that were unclear. But my overall takeaway from SVOC is that they were mostly not present in our samples, which again were taken from the surface months after the fire. So why were these concentrations generally low? The first factor I want to go over is dilution. And I'm going to walk us through an example where we consider that contaminant deposition could be equal by surface area, but pools do a great job of diluting those concentrations. So I know that soil was often tested, and this tested maybe the deposition of ash contaminants on top of the soil. And to make an example that might be a little bit more approachable, let's imagine that we are dropping sugar cubes. So if we want to test the amount of sugar in the top inch of soil for a square foot drop, we drop those 12 sugar cubes and that 1 square foot area, maybe we're going to measure 120 parts per billion for that square foot in that soil. If we then look at water instead, so let's take a 1 foot deep pool, and that we have the same cubic foot of surface area on which to drop our sugar cubes, but in that 1 foot deep pool, they are going to dissolve. So maybe we only have a concentration of 10 parts per billion in that pool. If we have a 2 foot deep pool, and again drop those sugar cubes, we're going to measure a concentration of 5 parts per billion. If we have a 10-foot pool, I hope you can see where this is going, drop those same 12 sugar cubes, our concentration is going to lower even more, potentially down to 1 part per billion. So if contaminant deposition is equal by surface area, pools can dilute a concentration of 120 parts per billion down to 1 part per billion simply by diluting that contaminant through the water. Another reason that concentrations could have been low is contaminant behavior. So sugar is a great example, but a lot of contaminants don't behave perfectly like sugar, dissolving and giving us, a perfectly sugary drink all the way throughout. So there could be poor mixing that would give us variable concentrations based on where we sample. We could also have contaminants that adhere to solids and thus sink down so that when we measure water at the top, we don't necessarily get them. And we could also have contaminants that volatilize. So that means that over time, they're going to go into the air. This will also affect the concentrations that we're measuring. Now, should we be worried with this? And I'm going to walk us through lead as an example to reassure that we have sensitive measurements and they are still low. So when we look at lead, the average we saw across the pools was 0.1 parts per billion. The maximum concentration we saw was 4 parts per billion. And let's even go all the way to 10 parts per billion. This is a drinking water threshold. If we consider how much lead is in that 10 part per million pool, if it's 5 foot deep, that's an average of 1.4 milligram of lead that has fallen per square foot. That's 566 milligrams in a 20 by 10 foot pool, so that's got 400 square feet of area. And we're measuring an eighth of a sugar cube's worth of lead in that entire pool. Additionally, with this slide, I want to make the point that for metals like lead, skin and swimming exposure is a minimal risk route of exposure. Drinking lead, not a great idea, but our exposure through our skin, the route to the bloodstream is going to be a bit slower. So again, a takeaway, please do not drink this pool water and please do not eat fish from these pools, but we might be less concerned from a recreational standpoint. I'm going to pass this back to Andy now.
Thank you, Dr. Proctor. So just to recap, the testing that was done looked for a number of heavy metals, a number of SVOCs, and none of them really exceeded any recreational standard limit. So the pools that we tested did not necessarily pose a public health hazard to people that were exposed to them. Why were the questions lower than expected? The takeaways, as Dr. Proctor mentioned, dilution, right? So when you put a little bit of something and a lot of something else, there's the material is spread out, right? And so there's less of it in the pool water that you would come in contact with. Also, as you know, rainfall and evaporation happen. And so there's a lot of changes that happen with these pools over time. And we know some people put water in them, some people took water out of them. Chemical sorption. So you have primarily for these things called SVOCs, like chemicals that are combustion byproducts, they stick to things and they like to settle to the bottom of the pool, right? So that debris on the bottom of the pool is likely has much higher concentrations than actually is sitting in the water above that debris. Volatilization is another concept that Professor Proctor mentioned, and you could think about benzene, for example. So you might have heard about benzene in drinking water after wildfires. If you had benzene in drinking in the pools after wildfires, what happens is with higher water temperatures, the benzene would actually evaporate into the air, and it would probably be at a very low concentration anyways, because the pool would be dilute. So really that's what we found, and that's why we think the concentrations were much lower than we expected. But as you all know, some of you have looked at some of those pools and said, this something just doesn't look right. Something's wrong here. And so the first really recommendation that we've had with households is, call your insurance company and see if they include covering your pool remediation as part of the support that we provide you. There can be situations where you do have to spend a little more time thinking about, what's going on with my pool. So if you have an oil slick in the pool, if your grill fell into the pool, when I was out there with the team in February, we saw dead animals floating in pools, structures, a house fell into a pool. And so you're no longer dealing with like deposition of dust and in debris, floating on the surface. You have other things, other objects in there that should ratchet up whether or not you need to do more to understand what's going on with that pool. And so in that situation, you'd want to reach out to pool fire remediation professionals. And those people are the ones who know how to protect their workers and you from the hazards as they're remediated. So if there's, for example, unfortunate dead animals in the pool, right, just taking them out and putting them on the pool deck is not, leaving them there is not a good idea. Those are biohazards, and you would need to deal with those specifically to prevent pathogens or disease from being caused with the people that come in contact with it as well. So there's some work that needs to be done there, but really there's two kind of categories of these pools. One is you're directly impacted and there's something wrong in a sense that it's um, this higher level of concern. And then there's pools that are kind of farther away where ash might have fallen in and they from a wildfire and the dilution effect takes over. So really, what's our takeaway from it? What I would like to say is this is the first study to put some evidence with recommendations. And so wearing correct safety gear is important. I've reached out to Cal OSHA and California Department of Public Health and asked them for advice on what they've been telling people for PPE. I know several pool owners reached out to us and asked for that as well. And I'm hoping that they respond publicly because wildfires are not just a Los Angeles area issue, but a statewide issue in the state of California. Have an electrician check the electrical connections, remove debris from the top and bottom of the pool, and also the pool deck. And then, of course, maintain and replace the pool filters. Removing particulates, the floating materials that might be suspended in the water is a good idea to do. There might be discoloration on the pool walls and the deck. Scrubbing those down with safe surfactants or soaps that are appropriate for the material that they're coming in contact with would be a good idea. If you drain the pool, you need to think about the cost of doing that, disposing of the water, as well as the cost to fill it up again. And then with pool draining, you definitely want approval from the wastewater utility before you discharge any water to the sanitary sewer, and I'll tell you why in a second. But when you run your filters to remove the particulates, that's going to help clarify the pool water and get it back to what it was. And then finally, of course, disinfect the pool to achieve proper water pH. And that kind of brings us back to making sure that the water is not harmful for the pool, stainless steel and other things, but also for the people in it. And so that's really important. So special attention is needed if you have a high particulate loading in the pool. If you don't remove the debris first and you just run your filters, you might burn out your filters because they'll become plugged. And so you really want to remove this. And this is just a basic concept of drinking water treatment and wastewater treatment. We try to remove the big stuff first, and then we polish the water with filters. Um, Applying large amounts of bleach to the pool produces a chemical reaction with all that organic like material that's in there. It doesn't have to be floating on the surface. It could be in the water. And some of that can be harmful if you put too much bleach in, for example, and cause too many chemicals to be produced. And so we did see some images of pool workers not necessarily wearing PPE with like 15 or 20 bleach bottles around. And for those people doing that, you just need to be very careful about adding that much bleach in one spot because of the hazard associated with chemical reactions. Overdosing the chemicals, there is an issue with too much chemical because you can actually change the water pH or make the water corrosive. And if you leave the pool there, it can actually corrode out the stainless steel ladders and other stainless steel things in your pool, and you'll have to replace them. Discharging pool water to the sanitary sewer can actually cause sewer backups in nearby buildings. And so the sewer pipes buried in the ground are of a certain size and expect a certain flow rate. And so if too many people or one person discharges all the pool water there, it might be too much water for that little pipe. And then you can have sewage overflows in other people's homes downstream. So that would not be a great situation. So you want to definitely talk to the sewer utilities before discharging the pool water. And then, of course, don't discharge pool water in a septic tank. I recognize many people who were affected by these fires in the Los Angeles area don't have septic tanks, but for people that are listening later on, you can actually plug and ruin the leaching field and tank if you discharge pool water. So the bottom line here is the pool remediation recommendations will vary based on how impacted the pool is. And so one neighbor's pool might be heavily impacted where their structure fell into it, and another neighbor's pool maybe not as impacted. So you might actually have different cleaning regimes based on how impacted your pool is. And so that's really the takeaway message here. And we're happy to provide this new knowledge. And now what I'd like to do is kick it over to the panel. And what I'll do is I'll introduce the panel here and we'll take live Q&A. So if you have a question, please write it into the chat and we will take a look at it. We've been answering questions as we go along here, as you've all been listening. And we also have received several questions from people that signed up for the webinar. So we tried to design this presentation to address some of those questions, and we'll try to do our best for the others here. So you know Professor Proctor and myself. What I'd like to do is introduce Professor Monica Palomo. She is at Cal Poly Pomona. She's a professor of civil and environmental engineering, and she has been instrumental in the field aspects of this work. I'd also like to introduce Professor Sanjay Mohanty. He's at UCLA. He has been instrumental in much of the analytical testing and analysis of this work, and based out of course, Los Angeles. And then Professor Christopher Isaacson. He is based at Cal Poly San Luis Obispo. At the time this work was conducted, he was at the University of Southern California. And so we have 3 representatives from California in the area helping their communities, and we're just lucky to have them here. And so with that, I would like to ask Dr. Palomo the first question that I received. And that question is, when you were managing the field drop-off sites where you interacted with the public, what were their primary concerns when you talk with them about this study?
Thank you, Professor Welton. I think that the most common theme was that people was very scared of having this big, scary mass of contaminated water and not knowing what to do with it. It was safe just to treat, or they needed to put everything in the sewer and just get new water. And they were very overwhelmed. It was very unsettling for them. And they were very thankful that the team was there collecting samples and in locations that they were familiar with, that were selected to ensure that they feel comfortable to come and talk to us and to drop the samples. And they were very thankful for the work that was being done.
Thank you. Another question we received is, what is the website of where you can download the PDF for this presentation? And that is www.plumbingsafety.org. And we have a copy of that at the very end slide as well. The next question that came in pertains to the chemicals we tested for. And so one of the questions that we received is, and this is really directed to Dr. Isaacson, why did you test for the semi-volatile organic chemicals that you did? And does that include everything?
Yeah, so it doesn't include everything. Unfortunately, it's not really feasible to test for every organic compound. There's hundreds, thousands. The ones that we tested for were really targeted towards combustion byproducts. So things that have been detected in water, surface, drinking water in the past following wildfires was our target. And then we narrowed it down a little bit further, as I think Andy talked about with like benzene. You know, these more volatile compounds are going to volatilize from the water. The idea being, by targeting a more narrow range of compounds, we could then test more pools. It's kind of that balance, right? So yeah.
Good, thank you. Dr. Mohanty, the next question is for you. Did we test the pools for microplastics and PFAS?
No, we didn't test for PFAS, but we did test for microplastics. And what we found is very similar to what has been found in any pool water without any wildfire. So we don't believe that extra microplastic or wildfire didn't contribute to the contamination with microplastics. What was there is originally present because of tap water or everything that was used.
Thank you. Dr. Proctor, you already answered one of the questions, and the question that came in was, lead was sometimes found at very high levels in Altadena soils. Did you find high levels of lead in the Altadena pools you sampled?
So we did not find extremely concerning levels of lead in any of the water that we sampled. And I think a lot of that has to do with the effect of dilution that I sort of explained with the sugar example, where if lead is depositing onto the surface, it's not being diluted by any water, but the deeper that goes, the lead is going to spread out throughout that pool so that the concentration can be much lower in the water, even if the deposition of lead is the same. So I don't think these results are incongruent with soil testing. They're just testing a different thing and in a different way.
Thank you. A question for Dr. Mohanty. An individual said that they had their pool guy rinse off ash-covered filters. They were diatomaceous earth filters into a dirt area by their house. Is the soil now badly contaminated? Should I get rid of that soil patch? My filters look like they were covered in gray pudding.
I just answered that question by chatting. What I believe is that it may not be contaminated, but the level would be only we can confirm if we do the testing. Because we know that pool water didn't have that much pollutants, but us may have. Once you add that to soil, it might be diluted over time, so we don't know exact number. So I would encourage you to send that soil samples to USC Clean. That's a free testing effort. You can get a number. After that, if the level is above the threshold, you can decide whether it's worthwhile to remove that topsoil or you don't have to do anything if it's below the limit. So I send the link there so that they can send the samples.
Thank you. Another question to Dr. Proctor and maybe Dr. Mohanty. Why wasn't testing done at the bottom of the pools? Wouldn't there be concentrations down there that could create issues?
Right. So I didn't type out an answer, but to address it for everyone, it really depends on the nature of the contaminant. So some contaminants might adhere to those solid debris and sink to the bottom or even float to the top. But one of our big concerns is we were going into water that we didn't know the concentrations of anything. And we were concerned about the safety of not only our team, but all of the participants involved in the study. So homeowners were collecting their own water. So that's part of why we sampled from the top. We also think that this could be representative of water that you might be exposed to. I'm not sure if Dr. Polma wants to add more.
I can add on to the challenge of collecting the bottom of the pools. Many of the locations, the device that we use, we could not get that bottom debris. We use a screen that by the time you take it up, it passed through that water column above it, so it becomes washed off again. So the ideal way to do the bottom sampling is having a vacuum filters, which is basically put the vacuum right in the bottom and the shock all that debris, and then you do the testing. We didn't have that tools. So our goal was to just measure the concentration in water itself, not everything that deposited at the bottom.
Yeah, thank you. And I will add, having done like industrial contamination disasters work, it's very common to cautiously approach something with personal safety in mind. And so what I think this study shows is that we know something now that we didn't know before with real evidence. It's not conjecture, there's real evidence here. And so the next effort for individuals experiencing this would be to go after what the debris is exactly. And you might have differences there. In further, it's always a good idea, like we recommended, to remove the debris, right? So remove the floating debris, remove the sunk debris, and then that should remove a lot of contamination that exists. Okay, so other questions that we have. So why was the water black and opaque? Is it just carbon soot? And maybe we will kick this to Dr. Mohanty and Dr. Isaacson.
I would, it could be a different reason, but normally the ash and everything that falls off after a fire, the black carbons that we see on the rooftop or as well as windshield, and that's where all the things dumps. So I believe this is a combination of that, but I don't think any reaction happens because of that. It become black. Must be the debris. And we have not also observed this similar color when pool is covered. So that indicates that if the pool is not covered, all the debris change the particulates or turbidity of the pools.
I mentioned Dr. Isaacson potentially to also kind of weigh in because he has firsthand experience degrading plastics that are initially black and dealing with the contaminated water after. Dr. Isaacson?
Yeah, so what I was thinking, if it is soot or debris, which it sounds like it could be, often that's going to be the source of some of those organics that we were talking about. So it's possible if it's very black, there could be stuff leaching off of, that thermally damaged material, whatever it happens to be. So being cautious with that, I think, would be important.
Thank you. An individual mentioned that a neighbor was told that they have to redo their entire pool because of contaminants being found on the surface of the pool water. Did the contaminants contaminate the pool plaster? And I can kind of address that. So first and foremost, if you drain a fire contaminated pool, you might find discoloration. You might find it used to be white plaster and now it's kind of gray. And that is the penetration of these organic chemicals that Dr. Isaacson was talking about. And sometimes, as Dr. Mohanty has found in his work dealing with stormwater, they can be organic acids and other things that are like not harmful. They cause discoloration. And so if you see discoloration of plaster, it could be simply because of staining due to that. And if it's an aesthetic issue, you can remove it. I haven't seen any evidence where people have ever looked to see what types of chemicals sorb into plaster. But we do know that if you scrub it pretty good, you can remove a lot of the particulate from the walls. And then, as Dr. Proctor mentioned, there's this dilution effect as well. So if you put clean water in, you're dealing with a lot different surface area than you would. The larger pools would dilute any contamination coming off the walls than, say, a smaller pool. Some other questions here.
Sorry, so I might jump in on one. Is it safer to rebuild instead of clean in case there are contaminants that stick to the pool material, like pebble tech that can't be washed or removed? And I think, based on what we've seen, there's not, even when the debris was in the pool, what was able to leach into the water was relatively low in concentration. So over time, that's only going to reduce, as that if there is any debris that's trapped in there, it's just going to, it might get into the water, but those concentrations are going to continue to go down over time. So I'm not sure that there's evidence to say that it's necessary to rebuild with a different material, but I'm not, yeah, Andy, did you want to add anything to that?
Yeah, I think it kind of goes back to, it depends upon how your pool is impacted, or the pool. It could be an HOA pool, could be a public pool. And it also is a decision about risk, right? Because this is the first ever study on pools where we're going to publicly releasing the data and providing evidence based on our recommendations. But we don't know everything because it is the first study. So it is a risk-based decision, but we think that if you do a thorough cleaning, you wouldn't necessarily have to do a full redo of your entire pool. There was another question that came in about our pool became a mud swamp. How do we get rid of that sludge? And what I would say is if you haven't engaged a cleaning company or a remediation company, not a cleaning company, but a remediation company, people that are professionals in handling this type of stuff, you probably want to go reach out to the local wastewater office, wastewater utility office, and ask them what to do about that. They may know haulers private haulers that they might recommend to come and suck out that sludge, because they're going to be responsible for disposing of it in a safe way. And so they may have contacts, the city or the county may have contacts too, and that would be someplace to reach out to. There was a question about if we drain the pool, will it collapse because of the hydrostatic pressure that might be on the sides of it? And that's a good question. It's probably pool specific. And I will tell that from a personal perspective. We have a neighbor once who didn't fill the water in the pool, and it basically collapsed because the groundwater table was really high. And so it caused pressure on the sides of the pool. That's not necessarily every pool, but that's a conversation you want to have with somebody who builds pools for a living and understands what the failure and responsibilities are associated with that, because that would be where the source of information you would want to get. The city or town engineers might have some thoughts on that as they permit these types of building sites, but people that build them for a living might also be those. One question that also came in is our pool is under construction. It isn't finished yet. Therefore, it doesn't have any water, but there's a bunch of debris in there. Do we need to worry about anything different? And so maybe I'll kick that to Professor Proctor.
Hi. So a phrase I like these days is dilution is the solution to pollution. It rhymes. So if there is debris there, I would definitely remove that solid debris if you can. But then over time, I think it'll be kind of the same approach as what you might find for other pools. As you fill up that pool, any debris might lower in concentration because of that continued just area for the contaminants to go into. So dilution is always a great thing. I think I answered another one where, if you don't have your filters ready, should we just keep adding water? There's nothing wrong with adding more diluent, assuming it's safe water going in.
Another question came in. Our pool was drained and the plaster was acid washed and then refilled. The water and plaster looked great, and then 2 months later, the plaster started to deteriorate and delaminate. Other neighbors in my area are seeing the same thing. What process has caused this? Well, that's a great question. And since this is the first pool study ever, that question unfortunately hasn't been answered. We would love to answer that question, and it would be pretty straightforward to do. What the theories are is potentially a number of things. First, depending on your pool liner, it could be the plaster itself. It could be UV degradation if it was drained. It could be the acid itself having some sort of reaction, or it could be just functionally it was old, in a number of other issues. So that's a great question that could be answered fairly easily. But what we found and what we typically find in these types of disasters is that the funding isn't able to support answering all the questions. But moving forward from here, if that's a question that the community thinks needs to be answered, then I would be loud about it and ask for it. We have about 10 minutes left, and we have another question here. Are you going to do any follow-up testing on more pools that had remediation? And now that you suspect that the heavy metals are sinking, would that change how you get the samples? This question is for Professor Proctor. And before you answer that, the question is, our soil came back high for arsenic, cobalt, and cadmium. So could those metals be going into our pool now?
So if we had all of the capacity in the world, I would sample everything. So we would sample from the bottom of the pools, we would sample filters, we would sample right next to the pool, we'd sample, the sludge that comes off the filters. But as Dr. Walton mentioned, we don't have the capacity to do everything. So I think, the water samples we took, I still stand behind them being representative of potentially a worst case scenario before debris is removed, with assuming a full pool. And it ideally is only going to get better as that debris is removed, as eventually filters are put back online to continue to remove things from that pool water. If there is a lot of runoff that's occurring, that would be a different question, because that is going to, of course, introduce more contaminants over time. So if that soil right next to the pool is continually adding cadmium or continually adding other metals into the water, that would be a different concern. But, if we were going back again, I'd love to see the remediation work. We were able to sample a couple of pools that did have a lot of remediation done even before we got there. We sampled one pool before and after it was replaced with fresh water. And we, after all that remediation and after the water is replaced, we didn't see strong differences. So again, we would love to, but can't answer all the questions. And hopefully what we did do was look at kind of a worst case scenario.
Thank you. There is a couple questions and statements about the urgency and need for plaster being tested and why it wasn't tested in this study. And I will say that that is something that we talked about in this study as important. We just didn't have the bandwidth to do it because we didn't necessarily know what type of contamination would be in the water column. So we wholeheartedly support understanding the plaster water interactions. As one of the listeners says, there's sometimes mold growth on the plaster, so that would indicate there's some sort of interaction with the plaster. That makes complete sense, and we do hope that somebody does look into that in the future. We're happy to do it. It's just not part of the existing study here. Another question: should we be asking our insurance companies to test? Well, I'll say, having worked in disasters for 20 years in helping people, you don't have to test everything. So the purpose of recovering from a disaster isn't to test everything that you touch. If there is evidence-based approaches to safely taking action to remove that hazard from your property and enabling you to get back to some level of safety, that's the way to go. And then when you walk into a situation where there's like a black pool with a number of other things in it, you approach that even more cautiously, right? And so you don't have to test everything, but some insurance companies are paying to do testing. I will say, in this home environmental testing report study we're doing, where people are submitting their home environmental testing reports to us, in another study, we are seeing pool water quality tests, and some of the testing approaches are irrelevant. They're testing for presence, absence of bacteria. They're testing for copper and lead, drinking water limits, and only. And so I really don't understand how somebody is who understands contamination and recreational water safety is able to make any claim that's scientifically defensible when you're looking for things that don't necessarily mean anything to somebody who understands what's going on. So there's probably a lot of pool testing that might be helpful, but I don't think we have seen any of those testing reports yet. Last question here before we wrap up. The U.S. Army Corps of Engineers drained somebody's pool. It is now dried with a tarp covering it. Will this result in the pollutants adhering to the wall to be harder to remove? I can't fill the pool right now because my home was destroyed and there's no water. There's no electricity, so I can't use the filter to clean the pool. Any suggestions? And so maybe I'll kick that to Dr. Proctor.
So one, I'm so sorry that you're going through all that. I think one of the things we saw is that, pool is one priority, but of course, getting a property to a living status where we can have water and electricity is a higher priority potentially than having a clean pool. So I hope that this pool owner gets to the point where they're able to add water and deal with that and add filters. But the pollutants adhering to the wall to be harder to remove. I'm not sure that we saw direct evidence that would occur. And again, always depends on the nature of the contaminant. So, potentially a power wash maybe might, be even easier at this point. than some pool owners who have it filled already. So just looking at the good side, but hopefully all of those other issues are addressed as well.
Thank you, Dr. Proctor. And thank you, panelists, for working together with us on this study. It was very helpful to all work together on this, and we're so glad to help provide some level of understanding to the people and agencies trying to help the communities recover. Tonight, I'd just like to say that we are kicking off a webinar series called After the Fires. And this webinar series, tonight's the first webinar. We're going to have a series of webinars, and the next webinar is scheduled for Saturday, September 20th. And that deals with the rebuild survey. So you might recall about the community survey that we led here at Purdue University with a number of other universities that you can see at the bottom of that slide. And we're going to be sharing results and discoveries from that, and also providing resources that people can use to take action to help themselves and their community recover. What's not shown here is there may be some other webinars that are added about property testing, remediation, and such. And we will add those on the website at plumbingsafety.org when they're available. So I want to thank Dr. Proctor and all the panelists again for tuning in and sharing their perspectives with everybody and the results. I also want to thank all the listeners for taking the time to share your experiences with us, to engage with us, and even if you were to just send, how you did in some cases, send text messages or emails just to let us know about things happening, that was wicked helpful. And that helped us basically better design the study so that we could try to get actual information. Questions about this event can be directed to Professor Proctor at lapoolstudy@gmail.com or myself. So with that, thank you very much. And this event has ended.